Muchas gracias, maestra Isis. A continuación tengo el gusto de presentar a Aleem Kalloo. Aleem Kalloo posee un título de maestría en Ciencias en Gestión Integrada de Costas y Océanos de la Universidad de Trinidad y Tobago, además de una licenciatura en Educación con especialización en Geografía y Estudios Sociales. Con una formación académica diversa y experiencia laboral, actualmente se desempeña como asistente de apoyo al aprendizaje o asistente docente en la Escuela Secundaria Malik, demostrando aún más su experiencia y compromiso con la educación. Bienvenida.
Good morning, everyone, and I'd just like to thank all parties for allowing me to make this contribution today. Okay, so I will be presenting to you my work on coastal change reduction of the southwestern peninsula of Trinidad using GIS and remote sensing techniques for the years 2014 to 2023, in collaboration with myself, Mr. Dinesh Ramsawak, and Dr. Arthur Potts overviewed this project to ensure its success. So just an outline of this presentation, I'll have a brief introduction, my methodology, results and discussion, conclusion, how does this relate to integrated coastal and ocean management, lastly, my acknowledgements and references. So my goal, very straightforward, very clear, to assess coastal change in the southwestern peninsula for the years 2014 to 2023, and my objectives are as follows: to identify the areas along the southwestern peninsula that have experienced significant changes, develop a classification scheme using previous literature, maps, and knowledge of the area, conduct field surveys to collect field points, map the land use land cover changes, and lastly, calculate the changes within the area. So on the screen, we have a figure that was retrieved from the ICZM Framework Policy in 2019 that shows the coastal zones around Trinidad and Tobago. If we look at my study area, the southwestern peninsula, that entire area is red, which means that it faces immediate impact for coastal changes through processes such as coastal erosion and so on. So Trinidad and Tobago has a diverse shoreline as any other coast along the world. And when we say a diverse shoreline, we mean different sediments and different structures. And I have two indicators listed here that tells us that coastal erosion is prone to occur within this area. Number one, young and unconstellated sediments, meaning that the material is very loose and it makes up the upper layer of the beach, as seen in image one, and the flow of the water within the Columbus Channel. This flows westwards parallel to the shore, removing sediments. So what is land use land cover? So according to the FAO in 2000, land use refers to the interface between land cover and human activities in the environment. So this basically tells us what the land has been covered with, whether it be urbanization, agriculture, and so on. Then we have land cover, and according to Ryasal in 2017, this can be defined as a biophysical cover that is present on the Earth's surface, simply meaning what is actually covering the land: agriculture, urban, forests, etc. Then we have land use change, which is the transition between one feature to the next over a period of time. So over the years, many supervised and unsupervised classifications have been conducted across various countries around the globe. But what is supervised and unsupervised? Supervised tells us that we have prior knowledge of the area, and we develop our training samples and allow the computer to run its algorithm, developing our classified maps. Whereas unsupervised means that we have no prior knowledge of the area, and we allow the computer to run its algorithm entirely on its own by simply stating the number of features that we want. Features meaning urban, forest, bamboo, etc. So here just shows a picture, a map from the distance between Trinidad and Panama, and it's approximately 2,156 kilometers. And Trinidad and Tobago is located southernmost within the Caribbean chain of islands, and my study area, the southwestern peninsula, is approximately 35.62 kilometers squared, and this was measured using the GIS tools. So why the study area? So according to the CSO in 2010, Trinidad and Tobago's population 70% of Trinidad and Tobago's population reside along the coast, and 80% of our socioeconomic activity occur along the coast. In addition to the ICZM framework policy in 2019, it stated that Trinidad and Tobago has always relied on its coastal zones for its economic activity. So that right there gives us two reasons as to why we should conduct land use studies along the coastal zones to sustain its stability to ensure our economic development. In addition, in 2017 and 2018, the Southwestern Peninsula experienced significant erosion, and it's so bad that the local government is saying that nothing can be done about this problem and that the local population should migrate out of the area. In addition, in 2019, we had a red palm mite which affected the coconut estates within the Southwestern Peninsula, and because of that, we have dwindling production of our coconut estates. So here, I have my methodology. For the data collection, I have where I collected my ground points, where I collected my satellite imagery, and so on. And the data processing and analysis, where I developed my classification scheme, where I developed my maps, and lastly, my results, where I conducted the change detection analysis. And each of these steps will be discussed in detail as this PowerPoint continues. So first of all, my data collection and acquisition. The satellite imagery was obtained from Plans database for 2023, and the 2014 image was an aerial photography obtained from the GIS online database. Ancillary data included the ground truth points, and this was collected using a GPS device. And the Planet satellite imagery was pre-processed in two ways: mosaicing, which meant that I took fragments of the image and put it together to create a whole, and clipping, where I cut around the study area to ensure I got exactly what I needed. So I then developed my classification scheme, and this classification scheme was obtained from the Anderson scheme in 1976. It was also adapted from a study conducted by Baban et al. In 2009 and a study conducted by Islam in 2020. And I developed 7 classes, and they are as follows: urban, forest, mangrove, marsh, agriculture/pasture, barren land, and water. And all of these images seen on the screen were collected by myself in the field. Data collection and acquisition, GPS ground points was collected on the 12th of April earlier this year, and the points were collected for accuracy assessment and for verification purposes. A total of 122 points was collected, 82 were for accuracy and 40 were for verification. So on the screen is the 2023 classified map. Now if we look at the legend, we can see that each feature is color-coded. So urban is in red, barren is in brown, mangrove is in orange, marsh is in gray, agriculture/pasture is in a lighter shade of green, and forest is in a darker shade of green, whereas water is blue. Now if we take a glimpse at this image, what we notice is that our urban development occurs along the coast. Next, we have the 2014 manual delineation. So what this means is that I drew polygons over each feature. So a polygon was drawn over urban areas, a polygon was drawn over forests, and so on. And of course, each feature was color-coded according to the 2023 image. Now here we have the 2014 barren land only. Here we have the agriculture mixed in with barren land, forest, mangrove, marsh. And as the slides are changing, we can see that each feature is being added together like pieces of a jigsaw puzzle. Here we have urban and water, which gives us the entire 2014 map. Now, once this was done, the accuracy assessment was conducted, and this can be used to determine the user's accuracy, the producer's accuracy, and the overall accuracy. And for this project, I got an overall accuracy of 79.27%. Here, we have both images. To the left, you will see the 2014. To the right, you'll see the 2023. And just taking a look at it, in 2023, we are seeing a lot more development occurring, where we have forests growing over our agricultural areas, we have a slight decrease in mangrove, and we also have more fragments of marshes throughout the study area. If we are to compare each of these features independently, firstly starting with barren land, to the left is the 2014 barren land, to the right is the 2023 barren land. And we can see that we have much more barren land in 2023, And this can be for a number of reasons. It can be as a result of a decrease in urbanization because we have erosion occurring so badly that's taking away homes, leaving bare soil exposed. It can also be because of a decrease in our agricultural lands, leaving bare soil exposed. Now, two important points to note is that this point, known as Coral Point, is experiencing significant erosion. However, this other point, called Ikakas Point, experiences accretion. So on one end, we experience erosion, whereas on the other, there's accretion occurring. So it's kind of balancing off itself in terms if we look at the barren land as a percentage. On one side, erosion, on the other side, accretion. Here we have agricultural pasture, and we can see the significant difference in 2023 as compared to 2014. We have a decrease in our agriculture. And then here, forest, we have an increase in forest in 2023, which is the image to the right as compared to the image to the left. So the quantitative assessment of land use land cover was conducted and compiled in this table. So for example, for urban in 2014, we had 1.25 kilometers squared. In 2023, we had 1.14 kilometers squared, which gives a reduction of 0.11 kilometers squared, or a percentage of 8.80% decrease. And this was calculated for each of our features and discussed in the conclusion. And they are as follows: 87.50% increase in barren land, and this could be for a number of reasons. It can be as a result of misclassification. It can be a result of the decrease in urban or the decrease in agriculture, leaving bare soil exposed, and as a result, a higher percentage increase in barren land. We have an 8.8% decrease in urban. So because homes are being destroyed by erosion, the population is leaving their homes abandoned, and we also have a 3.39% decrease in agriculture/pasture. And this can be a result of the parasite that affects the coconut estates during the dry season. It can also be as a result as the coconut estate is no longer viable, so persons are actually clearing the land for real estate. We have a 5.9% increase in forests. We now have overgrown vegetation in our agricultural areas. We have overgrown vegetation in our mangrove areas. And then here we have a 170% increase in marsh. And this, again, can be as a result of misclassification, or it can be a result as we have a decrease in mangroves. There are now more favorable conditions for marshes to thrive. We have a 7.14% decrease in mangrove and a 66.66% decrease in water. So how does this relate to integrated coastal and ocean management? So anthropogenic activities along the coast can both have positive and negative impacts on the natural environment. So regardless of what human activity we engage in, if we are clearing forested areas for urban development, we now have an increase in sediment runoff, we now have increased pollutants, whether it be plastics, etc. So it all negatively impacts our coastal zones. So by engaging in land use land cover studies, we achieve greater awareness of land cover features that can be used to develop and implement measures to protect our marine biodiversity. And with this being said, I would just like to add that land use land cover studies contribute to the identification, protection, restoration of sustainable beach resources by providing essential information on the current state of land cover, identifying sensitive areas, guiding restoration initiatives, and supporting effective management practices. These studies enable a holistic understanding of the coastal environment and aid in achieving long-term sustainability and resilience of our beach ecosystems. With that being said, I would just like to acknowledge the University of Trinidad and Tobago, in particular the Marine Sciences Department, and in addition to Assistant Professor in Practice, Mr. Dinesh Ramsawak, who supervised this project, in addition to Associate Professor Dr. Arthur Potts, and Assistant Professor Dr. Amalia Hussein. And that concludes my presentation for today. I thank you for your attention. So the answer to that question is yes. Because we can have a runoff of these chemicals into our coastal areas, it can kill fishes in addition to other marine organisms that thrive in the sand. Also, it's important to know that the southwestern peninsula is a home or hub to our local fishermen. So by having the increased runoff, it actually affects their livelihoods. Thank you. Yes, to some extent, this project was presented to the university as my thesis project, and now I'm sharing it here with you, and I hope one day that this project can reach a lot further.
Just a question about the methodology.
Yes.
You are associating the barren land cover with sandy beaches. So, and I'm not sure about the calibration. Are you sure that all the barren land is only sandy beaches?
No, barren land can be any exposed material. It can be exposed rock, it can be quarries, and so on. So in addition to sandy beaches, it also takes into consideration quarries, exposed rocks. If we may have cleared an area for development and it's yet it is yet exposed, it was considered to be barren land.
Okay, so how do you extract the coastal dynamics from the land cover and the barren land cover?
It has not been as yet extracted. However, future works, this is something that we intend to do and lessen the classes. So whereas we can just include sandy beaches apart from other exposed barren land.
Okay.
Thank you. Thank you so much. Take care.